I'm Anil Kumar. Welcome to my series on input-output machines and number patterns. Now, all of you are familiar with number patterns right from grade 1, they begin. And then we talk about input-output machines, iterative pattern rules, explicit pattern rules. And in this video, we'll take up some examples and also a test question. So let's see how all these things are related. So number patterns. Let's take a very simple number patterns like 2, 4, 6, 8, 10 and so on, right? So these patterns could be finite. We could just close them, let's say up to let's say 100, right? Or sometimes we write patterns which are infinite. They can continue forever. So we have number patterns which could have a pattern and which could have limited number of terms. These are called terms or infinite terms, right? So those are types of number patterns which you have done. Now, this pattern could be explained with the help of a rule, right? So we can write a rule for this, and rule could be start at 2 and then add 2 each time. That could be a rule, right? Now, some of you may like to write in a different way, a different rule, and that could be in terms of their position. So what we see here is that 2 is in position 1, this is in position 2, this is in position 3, this is in position 4, this is in 5, and so on. Now that position is also referred to as term number, or you can say position number. Right, so what we say, at position 1 it is 2, and then at position 2 it is 4, and so on. So we may say that this pattern actually is equals to 2 times n, right, where n is greater than equal to 1, right? So that is greater than equal to 1, starting from 1. So that also describes this particular pattern. So if n is 1, we get 2. If n is 3, we get 6. And if n is 5, we get 10. Now this kind of a rule, which I just talked about, is actually called explicit rule. And the first rule which we wrote is an iterative rule. So the iterative pattern rules are rules where we know the next from the previous, right? Start at 2, we know the beginning, and then add 2 each time. So repeat the operation. Do you understand? So that becomes an iterative pattern. An explicit pattern is 2 times n, right? So the advantage here for an explicit pattern is, if I want to know what is hundredth number in this number pattern. So if that is my question, in that case, for 100 terms, you will have to, for what is the 100th number? So you have to write all 99 numbers to get to the 100th term if you're using iterative pattern. However, with explicit pattern, you can use this formula. So it's a formula. So with explicit pattern, you know the rule is 2 times n, so n is 100, so 2 times 100 will be 200. So the 100th term will be 200. Is that okay? So we immediately found the 100th term. So do you see how these things are related? Okay, let's take another example, right? So let's take example number 2 now. So example number 1 was even numbers. Now in example 2, let's talk about odd numbers. Okay, so when I say odd numbers, I mean the pattern is kind of like this: 1, 3, 5, 7, 9, and so on, right? So that becomes the odd number. Now if I have to describe this, iterative pattern will be what? So iterative rule, pattern rule will be start at 1 and then add 2 each time. Is that clear? What is going to be the explicit pattern rule? Well, in term number 1 we have 1 and then it increases by 2 each time, right? So 2 times n. Now, and then what? How do I get 1 if I had to write this as 2 times n? Well, take away 1. So I could write this as 2 times n minus 1, where n is greater than equal to 1. Do you see that? So if I write n equals to 1, just see how it works. Let's see how it works. Okay. So we'll kind of make a table and then see how this works. 2n minus 1. Okay. So we'll now use our machine, which will have this 2n minus 1 thingy. So what we're trying to do here is that we have two parts. One machine, which will double the number. The other machine, which will reduce the number by 1. So we'll do 2 times n and then we'll do minus 1. Okay. To whatever numbers are coming from here, it goes through like this. Now in a machine, we call this as our input, right? This becomes the input and that is out. So we can feed in the number and see what comes out. For example, if I feed in 1, let's say, if I feed in 1, then what happens? At this stage, this 1 becomes 2 times 1, so we get 2, right? So this 1 becomes 2. And then when you take away 1, it again becomes 1, right? So the output is 1. Do you see that? Perfect. Now, if I feed in 2, then 2 twice is 4 and 1 less than 4 is 3 and therefore the output is 3. You get an idea. So we get 1 and 3. You can continue feeding more numbers, right? And then you will see how this pattern is repeated. So if I feed in 3, for example, 3 times 2 is 6, and when you take away 1, we get 5, and so the output is 5, we get third number. Perfect. If I feed in 4, double of 4 is 8, take away 1 is 7, so output is 7, we get 7. So that is how my input-output machine works, right? So I hope you have understood these links. So we have a number pattern which we normally talk about. You can explain the rule using iterative pattern rules, start at a number, add 2. And then you can also explain it using a formula, which I wrote here. And you can make a model like this. And this model which we're talking about is our input-output machine. Is that clear to you? Perfect. Let's take another example to make it more interesting. So what we will do here is, this time, we will do an operation on input and output. And what we have here, a machine which is doing something to our input. Let us say the input is right there and we get an output here. This machine times the number by 3 and then it adds 1. So it does two things at the same time. We'll write down different inputs. Let's say 1, 2, 3, 4 and 5, and then we calculate what happens. So if number 1 comes 1, this number 1 gets multiplied by 3 and then we add 1, right? So add 1. So what do we get? 1 times 3 is 3, 3 plus 1 is 4. So the output is 4. When the number 2 enters, it becomes 2 times 3 and then you add 1. 2 times 3 is 6, 6 plus 1 is 7. When the number 3 enters, it becomes 3 times 3 plus 1. 9 plus 1 is 10, and for 4 it will be 4 times 3 plus 1. 12 plus 1 is 13. Now what do you observe on this side? You do see that there is a pattern. We are adding 3 each time. Do you see that? So we do expect the next number to be what? We can do the reverse, right? Adding 3 will make it 16. Will it work? Let's check. 5 times 3 is 15 plus 1 is indeed 16, right? So like this, we can continue. And if I enter 10, then 10 times 3 plus 1 will be 31. So with this input-output machine, we actually have an explicit pattern rule. And the rule here is times 3 add 1. Right? So that is what we do to what? Times 3 add 1. To every input. To every input. So that gives you the output is equal to output. Is that clear to you? So that is how the input-output machine works. Correct? So if I give you a table, you can actually from the table also write down your rules, right? So what we learned here is if I am giving you an operation of input and output with the help of a machine, how to fill in and get the values. Perfect. Now important thing also to notice, since this is times 3, every number is increasing by 3. So if I have to write the rule, my iterative rule will be what? Iterative rule will be start at 4 is our starting number, right? So just start at 4 and then add 3 each time. Is that clear? And our explicit rule will be what? Explicit rule will be to every input times 3 plus 1, right? So the number n, you can write times 3 plus 1, or most of the time we write this like this, 3 first, then n plus 1. Is it okay? Always when we are writing explicit rule, we will take n value as more than 1, right? So where n will be greater than or equal to 1. Is that clear to you? So whenever you write explicit rule, take care that n is 1 and 2, 3, 4. Because these are term numbers. 1, 2, 3, 4, 5. N signify your term number, right? So where we'll define n is term number. Perfect. So in this case, if my question is, what is the 100th term? 100th term will be 3 times 100 plus 1 or 301. Is that clear to you? So that is how we relate all these numbers. Perfect. Now let's take another input-output machine, but this time what I will do here is in the input-output machine, let me write down the inputs and outputs. So we'll give you inputs and outputs. You need to find the rule, right? Let's say this time we start at to add 5 each time. So 7. Then we have 12, 17, 22 and so on. So we have input and output. How do we represent this as, let's say, number pattern? So we'll begin with number pattern. So the number pattern here is 2, 7, 12, 17, 22 and so on. Now input-output machine. So we say input-output. So as far as the input-output machine is concerned, what we see here is to every input 1, it became 2. We'll get to, but what we notice is that every number increases by 5, right? Every number increases by 5. So that means 5 has to do something with it, right? So if I multiply by 5, let's say we have an input And to our input, let me make two operations to make it simpler. We have the first operation as times 5. So if I do enter 1 here as my input, times 5 will be 5, but I need 2. How do I get 2? Well, to get 2 from 5, what should I do? I should take away 3. Does it make sense to you? I should take away 3. And then only when I feed in 5, 5 minus 3 will give me 2. Does it make sense? So this becomes my input output. You can check with 2. If I enter 2, then times 5 will be 10 and taking away 3 will be 7. So I do get 7. If I enter 3, times 5 is 15, taking away 3 will be 12. And for 4, 4 times 5 will be 20 and taking away 3 will be 17 and so on. Do you see that? So I get my input-output operation if I see this kind of like this. So that is how you can actually make input-output machine from the given input-output table, right? Well, describing this in terms of iterative pattern will be what? Start at 2 and then add 5 each time. As far as the explicit pattern rule is concerned, it is similar to input-output. For every input, you are multiplying first by 5, so we write 5 times n and then take away 3. So explicit pattern rules work with input-output. You get to understand this, right? So that is how you can actually connect all these. So I hope the examples are absolutely clear, right? Now, let's have questions for you to find input-output rules. So now I'll provide you with input-output table. So let me give you input and output. So let the input be 1, 2, 3, 4, 5. Okay. The outputs I'll give you like this time will increase by 4. Okay. Starting with 5, we'll increase by 4. So we'll keep on adding 4. So we have these numbers. So what I've done here is to get to the next number, we are adding 4. Right? Likewise. Now what are you supposed to do? Tell me what is the 10th number. Right? So that is what you are supposed to do. Also, write down the number pattern, input-output machine. Iterative and explicit formulas will come from these two. Okay? So that is what you're supposed to do. You can pause the video, answer this question, and then look into my suggestions. Well, as we see, the number patterns are 5, 9, 13, 17, and so on. So what are we doing here? We are adding 4 to each number starting at 5, correct? So let me write down this time iterative formula first. So iterative formula is probably easier, which is start at 5, add 4 each time. Okay, now these two are related, explicit pattern rule and input output. Since we are adding 4, we should be somehow multiplying by 4. So I start with my machine and say I should multiply by 4 first. Because adding same number is same as multiplication, right? So times 4. Now we'll do our testing. So we test with one number, which is the first number, and we want, when we multiply by 4, we get 4 here, correct? So let me just make some tables. So we are doing this operation. And now what? But we want 5. We don't want 4. Oh, so what should I do? Well, I have to add 1 to it. So I say I'll add 1 more. machine here, which is going to add 1. So if I add 1 to 4, we get 5. Do you see that? And let's test with second number 2. Now we know 2 times 4 is equal to 8. And when you add 1 to 8, we do get 9. It works. Do you see that? When I write 3, 3 times 4 is equal to 12. And when I add 1, we get 13. So likewise, we can say that the input-output machine is something like this. It's a combination of times 4 plus 1. You get an idea, right? So that is our input-output machine. So once we are very clear about it, we can say what is explicit pattern rule. So explicit pattern rule is equal to, we have to multiply by 4. This number input is our number n. So 4 times n, and then we add 1. So that becomes our explicit pattern rule. You get an idea. So if I have to find the 10th term, so what will be the 10th term? 4 times 10 plus 1, which is 41. So I get 41 here. So that is how immediately we can get our result. Is that clear? So I hope that helps, right? So the last example is for you to solve. I'll just provide you with the information here. You write down your rules, and especially I want this input-output machine to be made which can represent this input and output. It will be in 2 parts as I'm showing here, right? So we are interested in feeding in numbers, and then what we get here will be shown in our table. So this table has some inputs and some outputs. The inputs starting with 1, 2, 3, 4 are given to you, right? You have to make this input-output machine, and that is your test question, correct? So this time we are going to start by constantly with a number which is going to be, let us say 2. Okay. So times 2, that is by adding 2 each time. So we will add here 2 and we get 5. And then here we get 7, then we get 9, and so on. So for this machine, I would like you to write down what should be input-output operation, right? So that is what your question is. So I hope it is simple and straightforward. Feel free to write your answers and check with my comments. I'll provide you with the solution in the comments. I hope that helps. Thanks for your time, and all the best.